Imagine, just for a moment, an Earth surrounded by thousands, no, tens of thousands of artificial satellites. A sky crowded with blinking lights, each one part of a megaconstellation, orbiting our planet at dizzying speeds. Among them, Elon Musk's Starlink reigns supreme. But this marvel of technological achievement doesn't come without a serious concern, an unprecedented risk that some call the Kessler syndrome. A future where the chance of a collision between two satellites, or even space debris, could trigger a cascade, a chain reaction of crashes, creating a dangerous field of debris. An impenetrable belt, making space exploration, and even basic satellite functionality, a thing of the past. And you know what makes this scenario even more terrifying? The satellites aren't controlled by humans anymore, but by artificial intelligence. A single hiccup caused by space weather events like solar flares or coronal mass ejections, and these satellites could become non-responsive, unable to prevent impending collisions. But there's another twist to this tale, a factor that, well, I won't spoil the surprise. You'll hear about it soon enough. Hey there, Curiosity Explorers. Ready for another dive into the unknown? I'm your host, Caesar, alongside my brilliant commentator, Sonia, ready to embark on another exciting exploration with you.
Hi everyone. Always thrilled to be here, sharing in this journey of discovery with you all.
Don't forget to subscribe to Curiosity Wonderland, drop your thoughts in the comments, and share our podcast with your fellow curious minds. Your engagement fuels our exploration. So, shall we begin today's adventure? So, up until the 2020s and 2030s, we've launched an estimated total of between 8,000 and 9,000 satellites, with about 2,000 of them still active. But now, we're entering a new era, the era of satellite megaconstellations, and Elon Musk's Starlink is leading the charge.
Wow, so Starlink is essentially dominating the satellite game.
Exactly. As of this year, there are nearly 9,000 active satellites, and Starlink satellites make up more than half of them.
That's a lot of satellites. But what's the problem with that?
Well, the issue is that with so many satellites in orbit, a single collision could trigger a chain reaction, leading to an increase in space debris. This is referred to as the Kessler syndrome.
So, it's like a domino effect in space?
Precisely. And space weather events like solar flares and coronal mass ejections could make the situation even worse, potentially creating a new type of natural disaster, rendering Earth's orbit impassable for future space missions.
That sounds like a big concern, especially with the number of satellites expected to increase.
Indeed, just think of it, Starlink alone is proposing a total of 42,000 satellites. This could exponentially increase the risk of the Kessler syndrome. So it's a serious matter that requires careful planning and management. In the past, we could manually control satellite orbits and avoid collisions. But with these satellite megaconstellations, that's no longer feasible. We've had to bring artificial intelligence into the picture to manage the collision avoidance problem.
So, we're relying on artificial intelligence to prevent satellites from crashing into each other.
Yes, and while it sounds like a solution, it brings with it a whole new set of concerns. These satellites serve a range of purposes, from Earth monitoring to planetary exploration, and all of these missions could be jeopardized if the AI collision avoidance doesn't perform flawlessly.
What about Starlink's high-speed internet coverage? I've heard that's a big selling point.
It is a noble goal, indeed. However, we have to consider the potential collateral damage. The sheer number of Starlink satellites could interfere with ground-based astronomy and astrophotography. Plus, they pose a risk to our future space infrastructure.
That sounds like a high price to pay for faster internet.
Indeed, it's a complex issue. We're now relying on artificial intelligence to continuously adjust satellite positions for optimal internet coverage, compensate for orbital decay, and avoid collisions. Any interruption in this system could spell disaster.
So, it sounds like we're walking a fine line between technological advancement and potential catastrophe.
Exactly. And that's not even considering the possibility of the satellites becoming non-responsive due to some event. It's a risk we need to be aware of as we push the boundaries of space technology. Now let's talk about a natural phenomenon that could wreak havoc on these satellites: space weather. Solar flares, coronal mass ejections, and even the solar wind all send charged particles away from the sun. When these particles head towards Earth, our magnetic field and atmosphere protect us.
So, humans, plants, and animals are safe from this space weather?
Yes, the risk to living creatures on Earth's surface is essentially zero. However, our satellites in space are a different story. They don't have the protection of our atmosphere or the guaranteed protection of our magnetic field.
That sounds serious. What could happen to the satellites?
Solar energetic particles, which are essentially energetic protons, can penetrate satellite electronics and cause electrical failure. These particles can also disrupt radio communications.
Wait, doesn't the sun have cycles of high and low activity?
That's right. The sun has an 11-year cycle where the number of sunspots and hence, the solar flare activities, vary from a quiet state to a maximum state. We're currently heading towards a peak expected in 2024 or 2025.
So, we're facing an increase in space weather events, just as we're filling the sky with satellites?
That's the scenario. And it's not just a one-off event, the solar cycle repeats every 11 years. So, the risk to our satellite infrastructure from space weather is a recurring one. The impact of these solar particles on satellites can induce currents, cause electrical shorts, and easily cause various types of electrical failure. If this happens unexpectedly, the satellite won't be able to adjust its course, neither manually nor via artificial intelligence.
That sounds like a disaster waiting to happen.
Indeed, it's like a Russian roulette game of chance. With enough satellites in time, a collision becomes inevitable. Each collision produces new debris, which increases the likelihood and frequency of in-orbit collisions.
So, we could end up with a debris field surrounding our planet?
That's what scientists refer to as the Kessler syndrome. In a worst-case scenario, this could happen within weeks or months after the first collision.
That's terrifying. It reminds me of a story I heard about a remote-operated underwater vehicle that got tangled up in debris during a deep-sea exploration mission. It's amazing how we manage to create messes in every frontier we explore.
That's a fitting comparison. Coincidentally, I was reading about a recent event where two satellites had a very close call. They came within just 2 kilometers of each other, which is a very close shave in space terms. And with the number of satellites in low Earth orbit having more than doubled since last year, these near misses are becoming worryingly frequent. Now, space debris, as small as they might be, are already hazardous to our existing satellites and space operations. A piece of debris even collided with the International Space Station a few years ago, cracking a window.
That does sound like a serious issue.
Indeed. The scenario could get dire with hundreds of thousands of large satellites in low Earth orbit. A single collision between 2 large satellites could set off a catastrophic chain reaction. We could quickly end up with tens of millions of pieces of space debris.
Wouldn't that affect more than just communication satellites?
Absolutely. It would impact military and scientific satellites as well. Satellite technology would become impossible for decades, perhaps even several millenniums, until the orbit naturally clears.
That's a chilling thought. But doesn't the sun pose a threat too?
Yes, the greatest danger from the sun is a large-scale coronal mass ejection. If one were to head straight for us with the wrong magnetic field orientation, it could knock out power grids all over Earth, starting fires and causing trillions of dollars in damage.
Is there a way to predict these solar events?
Fortunately, we can monitor space weather with solar telescopes and observatories. We have observatories on Earth, in orbit around the Sun, at the L1 Lagrange point and in orbit around Earth. These allow us to assess the risk to our planet while the space weather is on its way, before any satellites are impacted. So, when a coronal mass ejection extends equally in all directions from our perspective, it's likely headed right for us.
And that's dangerous for the satellites?
Oh, very much so. They're vulnerable to coronal mass ejections, solar flares, and even the solar wind under various conditions.
So, what can be done to prevent this?
Ideally, when a solar flare is emitted, all satellites should enter a pre-planned safe route orbit. These orbits maximize the distance between satellites for the longest time possible.
Could that really work?
It could buy us some time, even years, until a collision occurs. But the problem is, no such failsafe has been built into any satellite megaconstellation from the beginning.
So, if we don't prepare, we could be dealing with a space disaster?
Absolutely. Unchecked, this could lead to what I call Flaremageddon, where debris from colliding satellites sets off a chain reaction, making the environment around Earth impassable.
That's quite a grim picture.
Yes, failing to prepare today could lead to catastrophic consequences tomorrow. We need to act now to avoid a disaster in the future. Now, let's imagine an even more bleak scenario. A magnetic reconnection event occurs, launching an X-class solar flare with a coronal mass ejection right at Earth. The magnetic field of the Sun, relative to Earth, is oriented so that a geomagnetic storm occurs, knocking out some major electrical grids in the process.
That sounds devastating. What happens to the satellites?
A large fraction of satellites get bombarded by these energetic particles from the Sun, causing them to become non-responsive. 8 days later, the first satellite collision occurs. As humanity scrambles to respond, a second collision occurs, triggering the beginning of a chain reaction.
The chain reaction you mentioned before.
That's right. By the year of 2037, the International Space Station is forced to be abandoned, our Earth monitoring satellites in low Earth orbit are knocked offline, and the Hubble Space Telescope is destroyed. Tens of millions of pieces of debris then fill low Earth orbit, making any subsequent launches impossible without the launch vehicle itself experiencing impacts from this debris.
So, we're talking about a total shutdown of our space operations?
Yes, it's an entirely avoidable disaster. But unless we prepare now, in advance of foreseeable disasters, we run the risk of mortgaging our entire species' future in space, all because we failed to take the necessary precautions. So to just recap, the rise of satellite megaconstellations, like Starlink, could lead to a potential Kessler syndrome scenario, where one collision sets off a chain reaction leading to a significant increase in space debris. If a space weather event, like a solar flare or coronal mass ejection, renders the satellites non-responsive, the likelihood of such a collision increases exponentially.
And without proper precautions, we could end up with an orbit so cluttered with space debris that future space missions become impossible.
Exactly. And the punchline is, we risk mortgaging our entire future in space just because we failed to take the necessary precautions.
Wow, that's quite the wake-up call. Thank you everyone for tuning in to today's episode. If you found this information interesting, please blast that like button, leave us some comments, and share the episode with your friends.
We always appreciate your engagement. Stay curious, stay informed, and we'll see you in the next episode of Curiosity Wonderland.
Goodbye, everyone. Stay safe out there, whether on Earth or in space.
The information for today's episode was gathered from an article titled Will Musk's Starlink Satellites Lead to Kessler Syndrome? By Ethan Siegel, published on Big Think on September 28, 2023. The full URL is in the video description if you want to delve deeper into the subject. Now I'm signing off, take care everyone.